Okay, so this is Jonathan Oxer's talk on anatomy of a Debian package. Specifically, we've asked him to talk about how Ubuntu packaging works. John is the president of Linux Australia, which is a Linux advocacy group in Australia, obviously, and he's one of the 3 authors of Ubuntu Hacks from O'Reilly. Apart from that, he's an all-round good guy and from some crazy other country. So anyway, here's John.
Okay, what I'm going to talk about is Debian packages, and I'm going to use Debian basically because that is the basis for Ubuntu. But essentially it's the same thing. The tools are all the same, the package formats are the same. It's all very much the same thing. So we're going to cover binary packages. I'm going to make a couple of assumptions here as well. How many people here are sysadmins? I assume there are a few. So I'm assuming that most of you are quite familiar with RPM. Yep. You played around with that a little bit. How many people have played around with Debian packages already? Yeah, a few of you. Okay. So I'm preaching to the converted. What I'm going to do is talk about the structure of a binary package, source packages, how you convert a source package into a binary package, and also a little bit about what's happening with some changes that are going on right now with the format of the Debian package itself, with the 2.0 format. So basically a deb is just an archive that contains several items. What I'll do is, these slides are going to be available for you to grab, but they're really just sort of reference. What I'll do is show you most of it live, so we might as well go around and start playing with a Debian package. What I'll do is grab, what do I get? We'll grab an existing package, like say TCP dump, and have a look at it. So if you do R, we'll have a look at what's in it. It's really just those 3 elements. There's Debian binary, which is just a little text file. All it contains is the version of the packaging system that's been used to create this particular package. At the moment, that's 2.0, which is the new package format. Control.tar.gz, which contains meta information about the package. So that's things like maintainer scripts and various other files that control how the package has been built, and we'll have a look at those in a second. And data.tar.gz, which is basically data for the actual file system. So that's what's going to get sucked out and then schlepped onto the file system. And then other manipulation will be done to it. So an actual binary package is a very simple sort of format. And if you want to, you can actually create it just using regular tools, but that's pretty painful. So it's much better to use tools that are designed for it. In the early days, of course, this is how all Debian packages were created. You just use R and things like that. But there are tools like dpackage, which is a suite of libraries and user space binaries that you can use for manipulating packages, for creating packages and things like that. So instead of having to extract it all manually, we can use dpackage. So if we did something like this on the package, you can get a whole lot of meta information about it. In this particular case, what you'll notice is that in a little while we're going to be looking at some of the files that are inside the package, including the control file. And what you see here is very much what's in the control file. So it's got things like the section that this particular package goes into, so packages can be categorized, the priority level, what architecture this particular binary package has been built for, and a number of things like that, and a description of the package itself. So dpackage basically provides you a really simple interface to be able to talk to the package or interrogate it directly and get information from it. And also, I should explain the way the packaging tools work in Debian is they're very layered. Right at the bottom level, there is the actual package format and dpackage, which manipulates it directly. Now, if you've played around with a Debian or an Ubuntu box, you've probably done your apt-get install or something like that. apt essentially is sort of like a wrapper for the low-level dpkg libraries. And then and that apt itself is actually not intended as a user space tool or as an end-user tool. That is really intended to be a mid-level layer, which is then wrapped at a higher level by things like deselect, synaptic, all of those sorts of user space tools that you then use to manage the packages installed on your system. The thing is that apt is so cool that people end up using it directly, and that's what I do all the time. So when I'm managing packages, I normally just do it off the command line using apt or dpackage. So the actual control file Well, when we had a look at what was in that binary before, control.tar.gz, what it contains is a whole lot of information about the package. So the package name itself. So the file name itself is not important. The actual name of the package is stored in the metadata. The actual source. So this is another thing that's interesting about Debian packages. You can build multiple binaries from a single source. You might have, well, PHP is a good example. Within the original PHP source tree, there are a whole lot of modules that are built out of it. So when you have, on the end user system, you might want to have modules available as separate packages, not one monolithic PHP package that includes everything. So what happens is you can have a single source package which encompasses the entire PHP source tree, and then define multiple binary targets so that when you run your build process, you end up with a package which contains the core PHP infrastructure, and then other packages that contain all of the supporting modules that might be optionally installed. So in the actual binary package itself, you need to be able to figure backwards where this package came from. So the source metadata tells you what source this particular binary came from. The versioning within Debian packages is consistent of two parts. There is obviously the upstream version, so if you've got version 0.9.4 or something, that may not change even between Debian package releases. For example, you might find that there is a security flaw and you need to patch and re-release a package, or you might find that there is a problem within the packaging itself. So you want to bump the version number without bumping the upstream version number, because that's always important to know where that came from. So the version of a Debian package is always in two parts. There's upstream version, then a hyphen, and then the version of the Debian package itself, which can also be composed of multiple parts. There's typically just an integer which increments. So you might have version 0.9.4-1 of a package, so that'll be the first Debian package built from that particular source version. And you can also have, you can add a colon and then another version to it. I won't get into that right now, but that's useful if you're doing things like non-maintainer uploads, or you want to bump the version number, but you don't want to, just as a temporary thing. But we might get back to that later. The actual architecture, the source package might be built for a whole bunch of different architectures in a build farm or something like that. So the architecture for the target deployment is important. And then the really interesting bit, and this is one thing that makes the Debian package format a little bit different to some of the others, is all of the relationships between the packages and the way the dependencies are handled. Within the metadata, you can specify depends, recommends, suggests, replaces, conflicts, and enhances. And that defines that controls what happens when you try to install a package using a mid-level or a high-level tool like apt or synaptic or deselect. What they can do is make use of this meta information to decide what other packages also need to be installed. So basically it gets around the whole RPM dependency hell sort of thing, which has been largely fixed up in recent time, but for a long time this was a very big distinction between the way Debian packages are handled and the way Red Hat packages are handled, for example. The different meanings of those, I won't go into that in great detail, but things like conflicts is fairly obvious. Basically, if you name another package, that package can't possibly be installed while this one is installed. So if you try to install it, the system will go away and uninstall that other one behind your back. But it will give you an option generally, telling you to let you say whether you want it to do that or not. Depends, recommends, suggests are just different levels. And then decisions can be made within the management tools as to whether they're going to be acted on or not. So depends, obviously, another package has to be installed for this one to go in. Recommends and suggests are just lower levels of priority. Enhances is like a reverse relationship. So once again, you can see this particular package enhances that one over there. So it's basically a backward relationship rather than a forward relationship. Yeah, in this particular one, you can see it depends on libc6, libpcap, and libssl, but it doesn't have any other dependencies. There are also build dependencies, which we'll get to in a moment when we start looking at the actual source that all of this came from. Okay, maintainer scripts. within the package itself, there is the raw data that's going to be schlepped onto the disk, and then there are maintainer scripts that are run at various stages of the process. So as dpackage, for example, is extracting the package and putting it in the right place, you need to have hooks as a package maintainer to tell it to do certain things. And the way the Debian packages work are very flexible about that. You can essentially do arbitrary things at various stages of the installation process. Using pre-inst, for example, you can have a little shell script that does any arbitrary thing, and you've got full root privileges to the system at that point. So, like any package management system, basically, if you're maintaining a Debian package, you have full root access to every system that your package is installed on. So pre-inst is run prior to actually extracting stuff onto the file system. In general, it's recommended that pre-inst and post-RM aren't used. It's only unusual situations where you absolutely have to do something before your data is extracted onto the file system. Typically, you'll use post-inst and pre-RM. So post-inst is run once that data.tar.gz has been extracted, and it gives you the opportunity of doing things like asking configuration questions, or that's a deprecated way of doing it. It used to be very common to just poke configuration questions to the screen using the post-inst. So you could say, do you want to install it in this way, yes or no? And it was pretty typical to have prompts at that level. The problem with that is that it makes it very hard to build high-level tools like Synaptic on top of it, because you can't pass those questions through in a consistent way. So configuration questions at installation time now are typically done using a script called config, which passes questions in a very structured manner up the system so that they can be asked using whatever interface has been selected. So you might have some people that are running apt, and it'll simply be questions on the command line. You might have some people running in a GTK type GUI or Synaptic or something like that, and you want the interface to match the rest of the GUI. And this abstracts the actual questions and answers from the format of the way that they're asked. So to understand that process, the actual sequence that is run through when you install a Debian package, so if you've got a package sitting there on disk and you do dpkg-i for install, it invokes debconf and asks any questions that might be asked. So it then runs, and the answers to those questions are remembered for use later on. It then runs the pre-inst script, and we'll look at some of that in a moment when we actually look inside a source package. The actual package is unpacked so that data.tar.gz is extracted onto disk and everything's put in the right place. So at that point, it hasn't been configured, but all of the data is sitting there live on disk. So it then runs the post-inst script, and at that point, everything is there ready to go. So the package is fully installed. Now, if installation is interrupted partway through the process, you might get a number of errors occurring. For example, if you have a failure within the pre-inst script, you might find that the package ends up in an unpredictable state, so you won't have data extracted onto disk necessarily. So there's a lot of cleanup that's taken care of within the dpackage libraries themselves. It tries very hard, basically, not to leave your system in a state where there is a package that's half extracted. And at most stages, it will give you an option of doing a cleanup. And it usually asks sane questions at the time. Removal is just the opposite. It's pretty easy. It just runs the pre-RM remove and pulls everything off disk. Runs post-RM remove. When you're removing a package from disk, there are a couple of different options. Standard removal takes the raw data itself, such as binaries associated with the package, and removes those, but it doesn't remove configuration information. Because a lot of the time, configuration has been modified by a local system administrator, and you don't want it just disappearing on you. So typically, those are files that are not actually controlled by the package. They might have been edited locally. And so unless you explicitly state that you want to remove configuration information with a -- purge option to depackage, for example, you'll actually leave all those behind. So what you could do is apt-get install that same package again, and you'll end up back in the exact same configuration and the same state as you were before you did the remove. When you are creating a package, it can be very useful to explicitly state which of the files that are put on disk are configuration files so that it knows to leave them alone. Some of the configuration files will have been put there manually and the package won't have any idea that they exist. Others will actually have been put there by the system, and if you don't tell it to treat them differently, it'll simply remove them. Yes, you have a question?
Yeah, you mentioned the config script.
Yeah.
Is that used during the debconf stage in the install?
Yeah, exactly. So what happens is that debconf at that point will prompt you for answers to questions, which could be on the command line or it could be through your GUI. The answers to those are then stored within the system, and they're accessible within your script. So basically they're set as variables, and within your pre-inst or post-inst, you can then access the answers that the person has given and then make decisions based on it. So it's a way of separating out that logic from the script itself. So you don't ask the question at the time, you ask it in advance. So with the actual package itself, you can specify, if for example you were packaging Apache, you wouldn't want to, you might put in an example http.conf, but you don't want that just blown away when the package is removed. So you can explicitly state which files within the package are config information, and then they won't be removed unless that purge option is provided. So we'll look at a source package. Source package contains, well, actually we'll just start playing with some live stuff. For reference, this is the actual source pack, what's inside the source package. So there's the orig.tar.gz, which contains all of the original source. It's important to be able to get back to the unmodified source so that you can see what the package maintainer may have done. The Debian changes, which have been applied to that particular source tree, and the metadata. So this is what gets turned into the binary package with those three equivalent elements that we looked at before. So a source package, very similar. Once again, probably not any need to go through this right now because it's we'll see it live in a second. One thing I should mention here is the issue of policy. One of the good things about Debian is the policy that's applied to locations of things on disk, and it's actually quite strict. So when you are building a package, you need to make sure that everything is installed into the right location. And it's pretty common if you grab an upstream source tarball, for example, and you just do configure, make, install, it'll often stick stuff in user local or somewhere that's typically used for end user location. If you're building a package that's going to be installed system wide, then you need to make sure that binaries are installed into a standard location, which is typically bin or user bin or sbin or something like that. So one of the things that you need to do is go through and make any changes that are required to make files so that things are put into the correct location. Now, what I'll do, okay, so the Debian rules file is the file that controls how the package is built. What this contains is a whole lot of meta information. This is what forms, this is basically a make file. So when the actual file is built, this is executed, and it's got a whole lot of different targets in it. Now, when... Okay. Let's have a look at a real one. Okay, so what I've done is just grab the source. I'll remove the original deb that was in there. So what I'll do is create a source package based on this particular source tree, and I'll go through and show you all those files rather than go through on the slides. So first thing to do is extract the source. And take careful note of the way it's named. It's best if the actual directory is named the same as the version. And we'll see this in a moment. Now what we can do, if you were doing this the hard way, what you would do is create a Debian directory which contains all of that meta information. So what we need in there is a Debian rules file, which is the make file that controls the build process of the package. We also need a Debian control which contains all of the metadata, including section architecture, build dependencies, and those things we saw earlier. Now you can do all of that manually and then simply execute Debian rules to build the binary package, but that can be really painful. So there are a whole bunch of build suites around that you can use. Deb Helper is probably the most popular one. It's been around for quite a long time. So install Deb Helper and dhmake, and then what we'll do is use dhmake essentially to bootstrap an architecture around this that we can use to build a package. So if we do dhmake, there are a couple of flags we can pass to this. We'll just pass in the most important one. The only one that really matters is the path to the upstream tarball. Because what it's going to do now is examine the directory we're in, examine the upstream tarball that we are pointing to, and do its best to build all the metadata, the meta control files that we need to actually build this package. So it's going to ask a couple of questions. The first thing is whether you want a single binary target or multiple binaries. As I was mentioning before, we can set this up so that there are actually a whole lot of separate control files or separate sections within the control file that determine what binary packages are going to be built. In this case, we only want to build a single binary package out of this. You can also tell it that you want to set it up for a library or a kernel module or something like that. So we'll take the simple one. In this particular case, it's just going to be a single binary. We haven't specified a license type or anything like that. And what that's just done is created a directory called Debian, which has been filled with a whole lot of example files. You'll probably find that a lot of these you won't even need, but it makes a fantastic starting point because you can just go through and change values and whatever you need. So first thing we'll look at is the control file. So this is the we'll change the section. There's a whole list in the Debian Maintainers Guide as to what the acceptable sections are and things like that. At the end of this, there's a URL for further documentation from the Debian site. There's a whole lot of reference material that you can use. So section has to be one of a number of predefined sections. Priority, this is an optional package, so we'll just leave it as that. There are build depends that are set there. What is going to happen eventually is that we're going to end up with a source package and a binary package that we'll build out of this. People might want to rebuild the source package, but they need to know what they need on their system. On a typical end user system, they won't have GCC and things like that. So what you can do is put in any additional dependencies in here that people are going to need when they actually come to building the package, rather than simply using the binary package that comes out the other end. So what someone can do if they wanted to build a package is do apt-get install --build-depends, and it will examine this and then go and grab all of the build environment that is necessary to build this package. In this particular case, it's you can see a number of placeholders here. These will be fixed up automatically by the build helper scripts. So just stick a description in. That's not much use. And when you're putting in a description, it needs to be wrapped at 72 characters. And you also need to make sure that there aren't any spaces. The actual format of this file is quite simple. What we see here at the first section of the file down to the standards version is meta information that applies to everything that is built from this particular source package. After that, where it says package TCP dump, that's where it's defining the binary package that's going to come out of this as the end result. And you can actually have multiple sections. So if this was if we're going to be building multiple binaries, we could basically just define multiple packages in here, and it would come out. It would build multiple packages out of that, which means that you can't have spaces in your package description. So if you're going to have a multi-line package description, you need to separate it by a dot, and it also all has to be indented by one character. Otherwise, things get rather screwy later on. The other thing that you need to have a look at is the actual rules file. So this has been automatically created, obviously, but you'll probably need to go through here and make some changes. For a really simple package, which you can simply do configure, make, install, you might not have to touch this at all. The Deb Helper suite is quite smart at setting this up to suit the source tree that you've extracted it in. So basically go through here and have a look at the different build targets. So we can see here, it's setting some flags. If you need to pass anything to GCC, for example, at build time, then you can set them in here. And you'll see here the process that it's going to go through at the point where that binary is actually created. So there's nothing special you need to do. This is where to start playing with it. You'll also see in this particular one, because it's been built using the Deb Helper suite, there are a whole lot of calls to these little helpers to do specific things. Now the idea is to make it as simple as possible to build a package without tripping over ourselves and making typical human mistakes. So each of these little helpers takes care of a particular part of building the package. So you'll see install docs, for example, is a helper which is being called, and it looks for things like a Readme file in the original source tree, and it automatically sticks it into the correct place. So each of these does some little task, and you might find that you need to, if this, for example, ran as a GUI and we needed to put a menu item in, then we could enable the install menu option, and then there is a configuration file for that. And there's a man page for each of these as well. It's really well documented. So if you needed to install a menu, you would then create a config file that specifies the position within the menu structure that it needs to be located, the name, the icon, and various things like that. Likewise for all of these other options. And there are quite a few of them. There are a lot more than this as well. This is just the really common ones. And then finally it does the actual build of the binary. So other things that you'll find within here, there is the changelog that we'll look at in just a moment. That's quite an important file. Compat, which is just the compatibility version, essentially, of this Debian package. So that's just a number. Conffiles.x. All of the .x files are example files that have been created by Deb Helper. And you can basically just go through and delete them if you don't want to use them. So conffiles is the file I was mentioning earlier that specifies which files on disk are going to be configuration files. So if you had a whole lot of files that you put into, etc., you might want to list them here so that when you do a dpkg -r, they don't get pulled off disk. Dirs specifies which directories are going to be used, because what will happen when this package is built is it will create a little local lab, which is like a we're going to use fake root in a moment to build the package or build a binary within a fake root, and it uses a list of directories here to build a structure that it puts the files into. So if there are other directories that you need, you can list them here and it will build them for you automatically. One of the reasons for this, rather than simply building stuff on demand, is that there are some sanity checkers. This is all geared around trying to prevent you making mistakes. So if you use a directory which isn't listed in here, the sanity checkers at the end will tell you. Emacs, we'll ignore those. Init.d, if this is running as a service and you need to start it up at boot time, it's got an example init file, which in the control file is installed automatically. You'll find that pretty much all of the files that are in this directory are put in place using those little DH helper snippets that we saw earlier in the control file. So if you actually do use an init.d, all you need to do is rename init.d to, or .x to init.d, enable the little helper that puts it in the right place, and it will take care of it all for you. There are example man pages in there. There's the menu file. So if you actually wanted to put this in as a menu, once again, that's taken care of by DH menu. and the post-inst and post-rm, pre-inst and pre-rm files. As a package maintainer, this is basically where you're going to spend most of your time, is playing around in these. So there's not much in them right now, but these are a little shell that you then flesh out with the specifics of what you need to do. So you might find that to install a particular package on disk, you need to create certain directories or you need to move things around. You can arbitrarily do anything you like in here. Okay.
Do they have to be a particular? Do they have to be using a particular shell or?
No. You need to be sure that the shell is going to be on the end user system, because otherwise there's no way to execute it. If you had some really unusual requirement, what you could on a certain shell, what you could do is put that shell in as a pre-depends within your package. So that shell will get installed and then your package will be installed afterwards. But that's pretty rare. They're generally just done in Perl or Bash or something like that. So like most things, if you've got unusual requirements, there are ways around it. You can work the packaging system to achieve just about any end result. But take the path of least resistance. There's a readme.debian file. This is different to the readme file because when you are setting your package up, you'll probably have to make changes that cause it to deviate from the original source installation structure. So you can document all of those in readme.debian, and that way it makes it really easy for people to see what changes you've made versus what was actually intended by the upstream maintainer. Default docbase and watch. Actually, watch is a really cool little file. This is a configuration file that you can use with helper tools that let you track whether upstream has changed their version or not. So what you can do is define in here the actual place that you grab your source from, and by running a script, it'll go through all of your packages and check whether there have been new versions released. So if you're maintaining a whole bunch of packages, you don't want to have to be going back to the original upstream every day and checking, do you have a new version? So this just takes care of all of that in a really neat little automated way. So it can tell you, you have X packages to rebuild. Okay. So at this point, what we could do is simply run the Debian rules binary makefile, and we should have a binary package. But the thing is that there are a lot of things that you might want to do as a result. Like when you're building it, you want to do sanity checking and things like that. You want to sign the package for release. So it's typical to use something like dpkg build package as a wrapper for it. So instead of calling Debian rules binary directly, there are a number of others as well, like deb build, which then just wraps dpkg build package. So in this particular case, we'll get back out of the Debian directory. So we're just in the source directory now, which hasn't been modified at all. We've got a Debian directory which has been auto-generated. So basically I've done pretty much zero work other than bootstrapping the source package at this point. So if we do dpkg build package, and then we'll add, we'll build it in a fake root. In fact, we'll do, we'll let it run properly. So you can watch this and pretty much see exactly what it's doing. You can see that it's there were some DH tests right up near the start there, where it was going through and making sure that those little helper scripts had the correct configuration files and things like that. And then it's running through the process of actually doing the internal configure make that you would do if you were just doing this manually. And hopefully we get no errors. Oh yeah, and there are some really cool helpers as well. If you are managing a package where the source is maintained upstream in CVS or even Arch or Subversion or something like that, you can use CVS build package. And what that does is manages all of your package directly within a repository somewhere and pulls it down and builds it as required. And it also takes care of stripping out all of the things that you don't want to go into the package. Like if you do a checkout of Subversion, for example, you end up with .svn directories everywhere. So CVS build package or SVN build package take care of grabbing your package and then building it in the local environment in a clean way. Pass rates, okay. it always asks for the passphrase twice because it's there are two different files that are signed. The Debian package itself is signed using GPG, and at the moment the chain of trust is not really that complete. At this point, obviously, I'm acting as a Debian maintainer, so I've got the original source. The idea is that I should be trusted to understand what's going on within that particular binary. I should know that there is nothing that's been done within the source that we don't want getting to the end user's machines. So basically, I'm signing that to say, yes, I trust that this package is okay. That signature is passed on as a detached file. So ultimately, once this package is published, the signature can be traced back to the original maintainer that built it. The thing is that in the case of Debian and Ubuntu, there are build farms that do auto builds for multiple architectures. So what's going to happen is that the source package that I created and signed is going to be sent off to the build farm, and then it will be built on all 14 architectures or whatever are currently supported on Debian. The actual binary that comes out of that, obviously, I haven't checked. I can't necessarily trust the build D, because who knows whether it's got a modified GCC or something like that, or the linker might have been modified. So there are a whole lot of points along the chain where you need to be very careful in terms of authenticating the actual package to be able to say to an end customer, this package that you have installed on your machine can be traced in an authenticated trust path all the way back to the original source. So there are some issues with that, but there has been a lot of work done on that recently to include signature support within apt, for example, so that you can actually check signatures on packages. apt is now set up in both in Ubuntu and in Debian in the latest unstable to check archive signatures. So there are a number of archives that the packages are pulled down from. The system will check whether this particular package has been signed and whether it can trace that trust path back. So what we've got now in the directory back above us is a whole bunch of extra stuff. There is the diff that was created a little while ago when, which is basically the difference between the original source and what we've created. There is a changes file which defines essentially what has changed in this particular release. I'll show you the internal changelog in a second as well once we start incrementing versions, and we'll look at what happens when you want to release a new version of a package. There's the actual .deb itself with the architecture. So in this particular case, you can see it's been built for i386. There is the orig.tar.gz, and there right at the bottom is the actual source that we grabbed in the first place. So theoretically, what I could do is dpkg I that .deb, which is now a fully built binary package, and have it install onto this local machine. I won't do that because I've actually already installed it. There are some checks that we can do at this point just to make sure that that is okay. There are a couple of automation tools and also other build helpers I should mention before I get to that. I've been using dpkg build package, but there are a whole bunch of build helpers that you can use. Just about every Debian developer seems to think that it's a cool thing to build their own build helper, so there are actually a whole lot of them. CDBS has been very popular recently. That's a common Debian build system. So now that we've actually got a binary package that's been built out of this source, we can use either Linton or Linda to check the sanity of the package. What they will do is extract that package that we've just created into a little self-contained lab and go through a whole lot of policy checks to make sure that it's not doing anything silly. So if we run Linton on, and you can see here in the version number, we've got -1, which is the Debian package version essentially for this particular source tree. So this is going to come up with heaps of complaints because I didn't remove any of those example files. So it's a little bit anal about that. It makes sure that you haven't left behind any cruft that that was put there by the helper suite. So in this particular case, it's got a whole lot of warnings which are non-fatal. It's got an actual error in there right near the bottom, helper templates in copyright. And basically, that's because it created a copyright file for me because there wasn't one provided, and I didn't specify whether it was GPL. So, and it's noticed there are a whole lot of placeholders that I haven't gone in and edited. So, at the point where you're editing the all the files within that directory, you need to clean that up. On the changelog down the bottom, it's got wrong bug numbering closes. I'll show you the changelog now because that's. Oh. Where are we going? This changelog was auto-created by the helper. In this particular case, what it's done is set it up to close a bug. Within the Debian bug tracker, there are hooks into the package management system so that if you upload a package with a closes line in it anywhere, it looks for a corresponding entry in the bug tracker and closes it automatically. So what I should have done when I was first creating this package is put an entry into the Debian bug tracker saying I am filing an ITP or an intention to package of this particular package just to make sure you don't have multiple developers working on one new package at the same time. And then when the binary package is uploaded for the first time, that can be closed to state that I've already created this package, so it doesn't need to be looked at. So that's where that error came from. So that should have been saying it closed 1, 2, 3, 4 or something like that. Okay, so at this point we have a binary package which could be installed directly onto the machine using dpackage, but that's pretty boring. What you really want to do is put it up onto a package server, which is really just an FTP or an HTTP server, which is stored with a file that lists, essentially an index that lists all of the packages on that particular repository. So we won't actually do that now, but there's some very simple instructions there for doing it using apt FTP archive, which allows you to simply put a whole lot of binary packages in a directory, run the script against it, and it automatically builds the index file for you. So it makes it really easy to maintain a little private apt repository. Now, if this package had actually been incremented in version, for example, if 3.9.5 had come out, or I discovered that I'd made a mistake and I wanted to create a new package, you can use DCH-I to increment it. Damn, I don't have it installed. And I don't have net access, so I can't show that. That's basically, all that is a shortcut way of throwing you into an editor. All it does, essentially, is that, and auto increments the number for you. You can do the exact same thing simply by editing the changelog. So this changelog is read at the point where the package is built, and the version is extracted from this string. So if we did another dpkg build package at this point, that's the version that would be created. Okay, Wigan Pen format. This is a slight change that has been, if you're wondering, at linux.conf.au last year in Canberra. The favourite haunt afterwards was this little pub called the Wigan Pen, and a whole bunch of Debian developers got together and started complaining about some of the limitations within the current packaging format. And they came up with a plan to fix a couple of those problems. For example, by allowing bzip2 compression and allowing a tarball to be used instead of a simple diff file. It's one of the problems if you're maintaining a package that contains binaries of images, for example, is all of those changes have to be represented within the diff. And so what would happen is that people would do really ugly things like you encode JPEGs and stick them within the diff and stuff like that. So the new 2.0 source format allows you to have a tarball to represent those changes, which gives you a lot more flexibility. So you can just put arbitrary things within it and they're handled automatically. And also multiple upstream tarballs are supported. There are quite a few projects that have things like build time dependencies that might be libraries. What you see with a lot of projects is they start off with a little internal library that has been created as part of that particular project. They've got some requirement, and they can't find a library that does it. And so it's included as part of the original source. At some point, they often split it up so that they think, hey, this would be a really useful library for other people to use. So they make it available as a separate tarball, but it's all still stored within the same source tree. And that can be a bit of a problem to represent within a Debian package as well. So with the new Wigan Pen format, that's taken care of because you can actually specify multiple upstream tarballs as representing the source tree for the package that you are going to build. Other things that we haven't talked about, converting RPM to Deb. That can actually be done in a semi-automatic way, but like any format conversion, there are catches. If you have data that you need, for example, to create the deb, like the dependencies, that information may not be available within the original RPM. So there are tools like Alien that allow you to take an RPM, they rip it apart, and they try to figure out the equivalent structure for a Debian, and they build you an equivalent Debian package. They can be useful for quick and dirty conversions, but it's not really advisable as a long-term solution. Or it can be useful if you're, as a starting point to show you what you need to do. Rebuilding source packages. Now, at the point back up here, we built a number of packages. What we could have done instead of building a binary is build an architecture-independent source package. So we didn't actually create one here, but that's just a flag that you pass to dpkg build package. So that source package can be taken onto any target machine and then simply built for that architecture. Packaging kernels is a whole interesting topic by itself. There are some very cool tools that have been used for almost entirely automating the process of building and installing kernels, which is very useful because it means that what you can do is build kernels on one particular machine, have them wrapped up in a package, and then simply install them on as many target machines as you like without having to have all of the build tools installed on those machines. So that's actually a really cool thing. And package caching. So if you've got a whole lot of machines locally that are pulling down the same packages, you don't want them all pulling down packages and using up your bandwidth for each individual machine. So you can run a local cache. Some people do that, yes.
So one question I'm dying to find out the answer is, there used to be a time when Debian packages couldn't deal with 32 and 64. It sounds like that's fixed now, but are there tips for how to deal with mixed systems?
Yes. You're talking about a fat package that's got binaries that'll run on either?
Or just getting them to install two separate packages in such a way they don't clobber each other, or...
Oh, okay. That is not taken care of very elegantly at the moment. That is still a problem. What you find a lot of people do is install stuff within a chroot. Like a classic case is a Flash player, for example. So if you've got an AMD 64 machine and you want to install Flash player, it's not available in a 64-bit binary, and we don't have the source, so there's nothing we can do about it. So a typical solution to that is to install a 32-bit chroot and then run Firefox or whatever within that environment. There has been a lot of work recently to try to fix that problem. I know that Red Hat has done a much better job with that than Debian has recently. So I don't know a lot about Red Hat, but my understanding is that you can actually run 32-bit and 64-bit binaries interchangeably on, I think that's partly a library issue more than a packaging issue. Yeah, package caching. So yeah, there's a whole lot more stuff that's in there. Pretty much everything I've talked about, the commands and everything are in the slides, so you can grab these slides. It's lying. They're not actually online right now, but they probably will be in about half an hour. The package maintenance guide is a fantastic resource to work through. There are currently, I think, about 1,400 Debian developers and a whole bunch of people that are sort of unofficial Debian developers, so they maintain packages. And there has been a lot of work to put up really good documentation. Basically, the new maintainer guide takes you through step by step the processes I've been going through here and shows you how to start with an original source tarball and how to end up with a package. And it's also got reference information such as the sections that it can be installed into, that could be defined earlier. So that's definitely worth a look. And the background image, which I just think is cool, I grabbed from DeviantArt, so I had to give a plug for that. So, yep, that's it for today. Do you have any more questions? Yes?
To what extent are packages shared between Debian and Ubuntu? And do you see them diverging more in the future? Or?
That's a whole big political issue. There has been a lot of backlash from the Debian community. There's been a general feeling that Ubuntu has reaped the rewards, as it were, from all the hard work put in by Debian developers, and they're not given anything back. There is a project called Ubuntu, I think it is, which is Ubuntu backwards, which is working to take any of the changes that are done within the Ubuntu environment and then push those back into Debian. And the thing is that pretty much all the core canonical employees are Debian developers anyway. And so they have a vested interest in making sure that Debian is as up-to-date as possible. But there has definitely been a lot of tension. There have been a lot of people within Debian that feel ripped off, as it were, by Ubuntu taking all the glory for Debian's hard work. So you hear different sides of the story. If you ask anyone that works for Canonical, they'll say, we give everything back to Debian. And if you talk to Debian, they'll say, they don't give us anything. But the truth is somewhere in the middle. One of the issues is that Ubuntu tends to be more up-to-date because of their 6-month release cycle. And so the issue is largely things like library versioning issues. So they made the transition to a newer libc6 much earlier than Debian did. They made the transition to Xorg much earlier, which has ramifications on a whole lot of packages that depend on X. And so there was a whole lot of bleeding edge stuff that was pushed through Ubuntu, which has largely been pushed back to Debian. So Debian, in some respect, is starting to trail. And you hear people making jokes that Debian is now derived from Ubuntu and things like that. But yeah, there's a bit of back and forth there. Yeah, and a good question.
So one of the things that's always tricky is knowing what the machine looked like when a package was configured. So suddenly configure says, I've got SSL and I'm going to use it. Is there a way to find out, what was the configure, or what does this package assume or have in it? Or?
Yes, as in what has installing this package done to my system? What does it put in different places?
And what options does the package have pulled into it at compile time?
Oh, okay. That's kind of two different questions. The first one is that there is a list option in dpackage. So if we go for, so say I wanted to find out what the TCP dump package had installed on my system, we can just basically do a long listing format, and that shows what files were schlepped onto the file system at setup time. So these are all the files that the package management system knows about that are related to that particular package, which is a really good way of finding documentation and things like that. The other part of the question is in relation to changes. The simple answer to that one, but the naive answer is to look in the changelog, which you can see is listed down the bottom there, so changelog.debian.gz, which was installed automatically. So that was basically the changelog that was entered by the package maintainer. The thing is that to put that, you're trusting the maintainer essentially. What you're wanting to know is the difference between the original upstream source and then what changes they've applied to it to build the package.
Well, but even more than I'm looking for, so when you run /configure, it'll go out and auto-detect a whole lot of stuff.
Yep.
And I don't always know what features it turned on because they were there on the original build machine.
Right.
So you're looking for compile time flags, so to speak.
Well, compile time flags is part of it, and the rest of it is what did it auto-detect.
Could you look at the diff file to
Yes.
upstream diff file to see if there is what the compile time flags are?
To some extent, that will show you the difference between what was upstream and what was compiled, but not necessarily the compile time flags. The best thing to do would be to grab the source package and have a look inside it. I didn't build a source package when I built this one, but typically there would be, as well as the _i386.deb package, there would be a .src package, which is a shrink-wrapped version of the tree that I used to build this binary package. In your sources.list file, which you typically have well, here's an entry here. You typically have both deb sources, which is a binary source, and a deb-source. And this, if you enable this, what you can do is apt-get install source of this particular package name. It won't install a binary, it'll grab the original source tree that the maintainer used to create that package and install it for you in an unbuilt state. So you could then go into Debian rules, for example, which is the make file that then invokes configure make within the source tree, and you can see what it's done to it. So if they've explicitly overridden any build time flags, you'll see it in there. Yeah, any other questions? No? Okay. Well, thank you. If you've got anything else you want to talk to me about, come and see me afterwards. Thanks.